This is the 2024 Higher Level Maths Leaving Cert Paper 2, question 2. So the table below shows the prizes in euro that a player can win in a game, as well as the probability of winning each prize. The player wins at most one prize each time that she plays. Some of the prizes are given in terms of X, which is real. So the prize can be nothing, 30%, 2 euros, 40%, X minus 10 euros, 28%, and X euros is 2%. The cost to play the game is 10 euros, and we're told as well that the game is fair, and that means that the expected value of winning, taking the cost into account, is 0. Work out the value of X. Let's work out the expected value of X first. So we've got 0.3 times 0, so this is the probability of winning nothing. We're going to add 0.4, which is the probability of winning 2 euros. We're going to add 0.28, which is the probability of winning X minus 10 euros. And finally, we're going to add 0.02, which is the probability of winning X euros. So if we work all of this out, we will get, let's see, 0 here, we'll get 0.8 here, we'll get 0.28x minus 2.8, and then we'll get plus 0.02x out here. So let's just simplify this. If we do that, we'll have, let's see, plus 0.8 minus 2.8, that's just going to be minus 2. And then we have plus 0.28x plus 0.02x, that's plus 0.3x. Now what we want to do is look at minus 2 plus 0.3x being equal to 10 euros. It's a fair game, so this is what you're expected to win on average, playing over, let's say, an infinite number of times. This is what you're paying for each game. So let's just work out what x would be then. So let's see, we get 0.3x is equal to 12. And if you divide 12 by 0.3, that'll finally give you x is equal to 40 euros. I think that's all we had to do, work out the value of x. Yeah, that's it. Second one here, A and B are mutually exclusive events. The probability of A is 0.1, the probability of B is 0.4. Write down the value of each of the following. The probability of A intersection B, well, that's just going to be 0. Mutually exclusive events are just two events that can't occur at the same time. So in terms of Venn diagrams, you will have, let's say, A there, or what are we talking about here? We're talking about, A and B, so it's going to be A here, B here. There's going to be no intersection here, or at least if there is an intersection, there'll be nothing in the intersection. So the probability of A intersection B is going to be 0. And let's see, the probability of A union B is just going to be the 2 added. So this, in here you got 0.1, and here you got 0.4. So here you got 0.5. That's it for part B. C then, C and D are two other events with the universal set U. The probability of C is 0.5, the probability of D is 0.7. Find the maximum value of probability of C union D complement. So let's just draw this out and see what it would look like. This is our universal set here. We would have two circles here. This is, let's say, C, and this is D. Now the probability of C is 0.5, the probability of D is 0.7. We've got to work out what's out here, the maximum that could be out here. If this is 0.5 and this is 0.7, everything in here could end up here. So this would be 0.5 in here. So that would leave 0.2 out here. Now we can't really do that the other way. So again, if you have C and D here, you can't put 0.7 in here, because remember D is 0.7, because that would give you a negative number here. Because remember, C is just 0.5, so it would be actually minus 0.2 here. So that's not possible. So the maximum you can put in the middle here is 0.5, which would leave 0.2 here. That would leave C as 0.5 and D as 0.7. So outside here then would have to be 0.3 to make up a total probability of 1. So you add these two, you get 0.7. So 1 minus 0.7 is 0.3. So in other words, the probability of C union D complement is going to be 0.3. So this is the maximum. That's it. That's part C done. Well, yeah, point D I've done out already. I've done kind of a detailed explanation here, maybe too much, but let's see. E is the event that it will be raining tomorrow morning. F is the event that I will wear a coat going outside tomorrow morning. Explain why it would not be reasonable to assume that E and F are independent events. What I'm saying here is that two events are independent if the occurrence of one event does not affect the probability of the occurrence of the other event. So in this particular case, for example, if it rains tomorrow, the probability that you will wear a raincoat tomorrow increases or it changes. So in other words, if it's raining tomorrow, chances are you are going to wear a raincoat. You don't have to, but chances are you will. If it's not raining tomorrow, chances are you won't. The probability reduces. Similarly, if you wear a raincoat tomorrow, the probability that it is raining tomorrow increases. Now, we're not talking about causation here. We're not saying that if you wear a raincoat tomorrow, that's going to cause it to rain. That's not what we're talking about. We're talking about probabilities here. So if it rains tomorrow, the probability that you will wear a raincoat will change tomorrow. So therefore, E and F are not independent. So there are other ways of explaining this, but this is just my explanation here. Okay, so that's it for this question.